This lesson is going to be about distance and displacement. So the learning target is to be able to know the difference between vectors and scalars and the difference between distance and displacement. So for this lesson, we're going to be following the path of a UPS driver as he's out on his route. So our driver is going out for the day to deliver some packages, and he got his directions. He needs to go 4 blocks, drop off a package, 2 blocks, drop off a package, 8 blocks, and 4 blocks, and drop off a package. So he takes off from the UPS station right here. He goes 4 blocks, 1, 2, 3, 4, drops off his first package. Then he goes 2 blocks, 1, 2, drops off his second package. Then he goes 8 blocks, 1, 2, 3, 4, 5, 6, 7, 8, drops off his third box, and then he goes 4 blocks, 1, 2, 3, 4, drops off his last package, gets done for the day, and then he heads home. Goes back to the UPS station, and then heads home to see his family. Now, the next week, he can't make it to work, and so someone else has to cover his route that day. And so he gets the same instructions, same people are ordering stuff off Amazon. It's a good time to be ordering stuff off Amazon, getting a lot of books to be reading. And so this guy starts off, reads his instruction, goes 4 blocks, 1, 2, 3, 4, drops off the first package. Then he goes 2 blocks, 1, 2, drops off the second package. Then he goes 8 blocks, 1, 2, 3, 4, 5, 6, 7, 8, drops off the third package. And then he goes 4 more blocks and goes 1, 2, 3, 4, drops off the last package. Now, you can tell from here that these two guys had the exact same instructions, but they both ended up in different spots. This guy gets done here, dropping off his last package, goes back to the UPS station, heads home to see his family. Now, the reason that these guys had the same instructions, but they ended up in different places, because all they were given was the distance that they had to travel. All they were given was the distance they had to travel. They were given how much ground to cover. They had to travel 4 blocks, then 2 blocks, then 8 blocks, and 4 blocks, but they weren't given any more information outside of that. And so this type of measurement is called a scalar quantity, where we have an amount, but we don't have a direction. We have a magnitude, but we don't have a direction. We're given how far they traveled, and they traveled 18 blocks in total, 4 plus 2 plus 8 plus 4. We know they went 18 blocks, but we don't know what direction they went in. We don't know if they went out 9 blocks and came back on the same route. We don't know if they went 3, then turned and went 6, and then when they went 9. We don't know anything more about the distance, the ground that they covered outside of how much there was. We have no idea about the direction. So it's not as descriptive of a number as it could be. And so we're going to be covering what it looks like when a number has a direction in the next example. So let's say that after the fiasco that happened in the last group, we had our UPS guys updated their instructions. So now instead of giving just a distance, they are giving a distance and they're giving a direction. They're also giving a direction. They're giving not just 4 blocks, but they're giving 4 blocks east. This is called a vector quantity. Okay, a vector not only has a distance, but it also has a direction. So let's see how this plays out for our UPS guys. So same thing as last time. We start off at the UPS station, picking up the packages, and we're going to go out on a route that it gives us 4 blocks east. So we travel 4 blocks east, 1, 2, 3, 4, drop off a package. Then we go 2 blocks north, 1, 2, drop off another package right there. And then we go 8 blocks north, 1, 2, 3, 4, 5, 6, 7, 8. Another 8 blocks north, and then we go 4 blocks west. 1, 2, 3, 4 blocks west. And so we drop off our package, end up here, head back to the UPS station, right there, and then go home for the day. Now, our next guy, the week after, we got to substitute, so we don't always get the same person, so we've got to make sure that our directions still work. So, the next week, new UPS driver starts off at the UPS station, goes 4 blocks to the east, 1, 2, 3, 4, drops off a package, same spot, 2 blocks north, 1, 2, drops off a package, goes 8 blocks north, drops off the third package, and goes 4 blocks to the west, drops off a package, ends up there, goes back to the UPS station, and then goes home for the day. And so because we gave vectors not only a direction, we also gave a distance, we had a much, we had a really consistent way of telling somebody the directions on how to get somewhere. So we're not only telling them how far, we're telling them where to go. And you guys will inherently know this, that just makes sense. Now, this distance right here, if we look at the change in position that they had, the distance that every UPS driver had to take to get home from their ending spot, this is the change in position. Oops. Change in position. It's how far were they from their initial starting spot. Now, not how far they traveled overall, that'd be the distance, but this is the change in position. Another example of this would be if a UPS driver started off right here, went 4 blocks east, and then went back 4 blocks west, stopped here, their change in position would have been 0 because they didn't, they're not in a different spot than what they started with. Their distance would be 8 meters, 4 meters out and 4 meters back, but their change in position would effectively be 0. Where did they start with compared to where did they end up at? And this change in position is called their displacement. Their displacement. And this is a vector quantity because not only do we have a distance, but we also have a direction. So for example, the UPS driver's displacement from their starting point to their first stop would be 4 blocks. Right now, their displacement from their first stop to their second stop was also 2 blocks north. Right? But their displacement from their starting point to their second stop right here was not 6 blocks, the distance that they traveled. It was less than that. It's this direct path. So we are only looking at the change in position for our displacement as opposed to the overall direction. So some of you who are Despicable Me fans have probably seen this guy before. This guy's name is Vector. And if you ever watch the movie again, make sure that you're paying really close attention when he introduces himself because he says that he does crimes with magnitude, which is another way of saying amount, and direction. And so a vector is going to a lot of times be described as an arrow because not only does it tell us how long that arrow is, but it also tells us in what way it's pointing and what way that measurement is happening and what direction that's happening. As opposed to a scalar where we only have amount or magnitude, we could say that. We only have the magnitude. And so if we were thinking about distance and displacement and where these two landed, if we had the distance, remember, is how much ground is covered, and that just doesn't tell us a direction. Our displacement is a vector quantity because it tells us the difference in the change in position, and it tells us not only how much did the position change, but it tells us in what direction did the position change. And so hopefully by the end of this video, you're able to tell the difference between a vector and a scalar quantity, and you can tell the difference between displacement and distance.